All right. So in week 7, we're talking about functions. And first, let's talk about what is a function. Independent versus dependent variable. Okay, so a function is a relation, and by relation, we mean two quantities are related to one another. But specifically, a function is something that passes the vertical line test. So relation with only one output for each input. And we will talk about several examples of that. And so we might also say passes vertical line test. And so I know you've seen that in math class, and you're looking at the graph, and it's just, it's basically really straightforward to see if it passes the vertical line test, and you say yes, it's a function or not, but passes vertical line test. But perhaps more importantly is to talk about real examples and discuss whether they are functions or not. So dependent versus independent variable, it's difficult to not use the word in the definition for these, so I'm just gonna. So this depends on the independent. Sometimes the independent is called the control variable or the experimental variable. And let's say this is what is chosen. And so that's chosen, and then the dependent variable is affected as a result. So here's our first example. So cost of pizza and the size of the pizza. Excuse me. And so you know that when you go and buy a pizza, you choose what size you're going to buy, and then the cost is determined by whether it's a small, medium, or large. So this part of the graph is asking, is this relation, so obviously the cost is related to the size, is it a function or not? Meaning if we were to graph, let's say cost as a function of size, and it would probably be something like that. It would actually be more of a stepped graph like this because there aren't an infinite number of sizes of pizza. But do you see for each size there's only going to be one cost? So we're going to call this a function because it would pass the vertical line test. Now, the thing I like about these is you could argue either way. You could say, that's wrong, Mr. T. I'm going to order a medium pizza, but this medium pizza is just going to be pepperoni, so it's going to cost $10. Or I'm going to order a medium pizza and it's going to be an everything pizza if something exists like that. And so it's going to cost $11, in which case for one input size, medium, you would have two different costs. So I'm just saying this. It is, if it doesn't pass the vertical line test, we would say it's not a function, it's just a relation. And you could argue either way. Okay. Hours spent studying and grade on test. In general, people agree that if you study, you do better on the test. I've definitely had classes in college where I felt like no matter what I did, I would get the same grade. But we say that, so the number of hours spent studying, that's what you choose, it's the independent variable, and your grade on the test is a result of that. And I would say that this is also a function, because let's say you study for 3.52 hours, you're only going to get one grade on the test. You wouldn't end up with two different grades. Hours of daylight and season. So as we head into winter, the number of hours of daylight that we have decreases. So hours of daylight depends on what season it is. And this is also a function. These values are calculated down to the second, and so you know that if today is September 26th, there are going to be exactly a certain, based on your latitude, there will be an exact amount of daylight. Although you could argue, if you went to a different location, right, flew up to Seattle, you would have a different number of hours of daylight on the same day. All right, month of year and average temperature. And so again, this is similar. As we head into winter, our months change and the average temperature changes as a result of that. we could say, so for this September, maybe the average temperature was 63.2 degrees, and September last year, the average temperature was 64.1 degrees. So we might call this a relation. And again, that could be argued. Height as a function of age. So as you grow up, you get taller. So we could say that age is the independent variable and height is a function of that. And for you in particular, at a given age, you're going to have one specific height. When you're 16 years, 3 months, and 2 days old, you would never be two different heights. Though the question is a little vague, and this could be argued, well, every 16-year-old is not the same height, and so we could call that a relation as well. The given information, you see, is not super specific. Are we talking about one person, or are we talking about the human population, or people in Mammoth, or whatever? Okay, strength and exercise. We go into the gym to get strong. We train to improve. And so we can say that the more we exercise, the stronger we get. And this is totally vague. If it were for a specific person, after a specific amount of exercise, they're going to have one level of strength. If we're talking about different people or different exercises or different times of the year, we might call that a relation. And then time and height of afro. I'm sure you've been wondering what this picture of MJ is doing here. And so as time goes on, the height of the afro would increase until some point when gravity would take its toll on the fro, and it might be like this. Alright, but that would be a long time down the road. So we can say that as time goes on, the height of the afro increases, and his afro is only going to have one height, although that could be argued. Maybe he picked it out today, right? Or maybe he didn't pick it out today. So again, arguable. But I think these are kind of fun, and this discussion really helps students understand, what depends on what, and is that a relation or is that a function? Are there two y values? That kind of thing. All right. So first example, the amount of money you earn at your job last week is a function of the number of hours you worked. So let's say for this example that you earn $10 an hour at your job. So, that's pretty close to minimum wage, I think, at this point. So table of values, we could have time in hours, earnings in dollars, and notice how I have this set up in a nice table format. And I put this down here, a value of 40, because this is per week. So 40 hours per week, and you would earn $400 until taxes. And then a graph, we could have the dollars depend on the number of hours. So we have the dependent variable on the y-axis, independent variable on the x-axis. And to be more specific, we should probably say that this is in hours. The slope of this line would be 10. We weren't yet asked for the equation of it, so I just drew the graph. And then sometimes we talk about a function machine. This can be helpful sometimes where you think of the function as you put something in and you get something out. So we have an input and we have an output. Input and output. And for this function, you put in some number of hours and you get out some number of dollars. So if we're writing an equation, it would be something like our earnings are equal to 10 times the number of hours we work, or if we wanted to put it in a form that looks more familiar to us, y equals 10x, and then we might do something like define the variables. Y equals amount of money made, and x equals number of hours worked. Just to be specific. Okay, and then when we talk about domain and range, think about the situation. So domain, we're talking about possible values for time, and this was, in the question it talked about per week, you could just not show up, right, and you'd work 0 hours, or you could be full-time and you could work 40 hours. And sure, there's overtime, and this could be argued and whatnot, but Based on a 40-hour work week, this looks good. Notice how these are equal to. You could work exactly 0 or exactly 40 hours. And based on the domain, we can figure out what the range would be. Your earnings, based on these values of time, would be $0 and $400. And again, that is per week. Okay, so next example, we got 2 examples on the back page. Maybe the app is frozen. That's cool. Okay, Joey wants to get swole, of course, so he joins the local gym. There's an initiation fee of $50 and a monthly fee of $20. That's pretty cheap compared to Snow Creek or whatever. So, table of values. If Joey joined and then never showed up, he'd pay the $50 initiation fee. After 1 month, he will have paid $70 because it's 50 plus 20. 2 months, another $20. 3 months, another $20. So, table of values to help you picture what's going on. If we were to graph that, it would look something like this, where here's months and here's cost in dollars. And so at 0 months, we had $50. I essentially just plotted the points in the table off to the left. It'd be this nice straight line. Obviously, the more time he goes to the gym, the more diluted that initiation fee becomes. So equation, dollars per month and then dollars per year. So we could say that the cost is initiation fee plus 20 times the number of months. And if I wanted to write that in something that looked more like y equals mx plus b, we could write it like that. Y equals slope x plus b, y-intercept. And then if we're talking about per year, we know there are 12 months in a year, and each month costs $20, so it'd be $240 per year. I don't know what this thing is over here. So we'd get something like cost is the initiation fee plus $240 times the number of years. Let's get that guy out of there. And and then domain and range. So this could be argued. Joey could definitely belong for 0 months. Okay, he's not going to live forever, so this is an exaggeration. Let's say Joey joins as he's born and he lives to 100 years old. So then we can say he belongs to the gym from age of 0 to age of 100, and then the cost. What would this be? Okay, fine. I'll get the calculator. So if we're talking about 100, so it would be 1,200 months. Sorry. So 100 years old, 1,200 months, and if I do 1,200 times 20 plus 50, I end up with a cost of only $24,000 for him to belong to that gym from 0 to 100. And so, okay, so here's the range. It depends on the domain. Basically taking the values and plugging them into the original equation that we came up with. Independent variable is definitely time, the number of months for which he is a member of the gym, and the dependent variable, the cost, depends on how long he's a member for. Okay, so next, Joey wants to show off his muscles, so he goes to Hawaii and he's cliff diving. And he jumps from a 45-meter tall cliff. That's pretty tall. You should not try this at home. Although, I don't know, maybe you live in Hawaii. His height as a function of time is given. So this equation is given here. And based on that, we're going to figure some stuff out. So, table of values, I was basically plugging in 0 and 1 and 2 and 3 for time. This is in seconds. And the height, this is meters. Good. And so the height value that we get from here, so we see that he starts at a height of 45 meters and it takes him 3 seconds to actually hit the water. Whew! That would be an exhilarating 3 seconds. So the graph is going to look something like this. This is, you see the t squared. This is a parabola, not a straight line. And it would be like 0, 1, 2, 3 seconds. And height here, this was 45. And so we could split that up into 9 different regions, each of which would be 5. And so we'd have something like that. and this is height in meters. And that would be a downward-facing parabola. If we look at the equation, downward-facing parabola, right, we have a negative coefficient in front of the t-squared. All right, and height and time. So this is, notice how the variables are defined here. Height in meters, time in seconds. That's good. Given plus, given. Domain and range. So the time for which he is in the air is something between 0 and 3 seconds. And the height is something between a height of 0, he lands in the water, and a height of 4 and 5, he just starts up on the cliff. And so it's a little weird that this value corresponds to this value, and this value corresponds to this value, but that's how we would express it, domain and range. Independent variable is time, dependent variable is height, and if we were sort of describing this relationship in words, we could say as time decreases, the height decreases. As time increases, meaning goes on, height decreases. Thanks for listening.